This video lecture, we once again look at school revision, namely inequalities. Now, students are definitely familiar with inequalities as opposed to equalities or equations. So yeah, we first can look at inequalities and then apply those inequalities to our inequations. So what's inequalities? They relate to all the properties of real numbers. You know that when we have a real number system, and we've used, which is custom R for the real number system, denotes the real numbers. These are all the numbers that can be represented on the number line. At 0 and then to the right, we have positive values. To the left, negative values. With the real number system, of course, we include all values between the natural numbers or counting numbers or integers, whichever section of the number line that we are going to be working with. So we are, of course, familiar with the number line. What are the inequalities? The less than, the greater than, less than or equal to, greater than or equal to. I do that with a bit of contempt because it really just depends on the way you want to view an inequality. For example, take the first one here. X is greater than or equal to 2. Now, if I'm starting with X, when I indicate this inequality and I begin with reading as is customary in the English language to go from left to right, if I go from left to right, then I'm going to start with X. And of course, the bigger part of the inequality is on the left hand side. So I read this as X greater than or equal to minus 2. But there's absolutely nothing stopping you from going in the reverse direction, in which case you could say minus 2 is less than or equal to X. So whilst I've indicated all these as a less than, greater than, less than or equal to, greater than or equal to, it really depends on which direction you want to view your particular inequality. Well, in most cases, I will stay with the normal left to right indication or terminology. So let's take X greater than or equal to minus 2. That's fairly straightforward. We have just a X, and inequations can be solved very similarly to our normal equations. By that I mean remove brackets, transpose the terms, multiply by your LCD to eliminate fractions, and so on. What I'm going to really emphasize here is, firstly, the inequality. Another notation that could be used to represent that inequality. So in this notation, we know that for X greater than or equal to minus 2, we're going to take all numbers greater than or equal to minus 2. So we'll go on the number line. There's our minus 2. Numbers greater than minus 1, 0, 1, 2. But of course, all the values, the fractions, the decimals, which are bigger than minus 2 and includes minus 2. Now, in this case, if we want to write that in interval notation, we use the square brackets. A square bracket means that that particular number next to it, minus 2, must be included in the solution. And then that goes to infinity. So yeah, everything going to infinity after that. And infinity normally has a round bracket. So interval notation, also important. You're going to come across that. And another thing to remember too is when reading textbooks, they can go in depth with these. They can call it closed and closed and closed, or open and closed, or closed and open. I'm not going to go into detail there. And what I mean by that, -2 is closed because -2 is included. Of course, on the number line, if we want to take that inequality and represent it on a number line, I think I'm just going to use freehand here. Don't want to be too technical and too accurate. I would like to, but that would mean going into Word or PowerPoint and so on. So I'm just going to draw, is that a straight line? It is a fairly crooked line. Anyway, I'll try my best. So we're going to draw and graph a number line. And the only thing we need to indicate for this example 1 is -2. Possibly include numbers to the left and to the right. And -2 is included. Maybe we should just take another color. Let's choose another color. Say blue. So -2 is included and it's greater than -2. So we'll indicate that as the graphical representation of the inequality x greater than or equal to -2. Now, I'm pretty sure you are familiar with that. I'm just emphasizing a few things. So let's proceed. Don't want to stay too long on all of these. Let's take the next one. X greater than or equal to 3, less than 7. I just want to indicate firstly our interval notation while 3 is included. So, okay, let's go back to our red. 3 is included, so I'm close that, square brackets, 3, and that goes to 7, and it's less than 7, so it's an open bracket. So x greater than or equal to 3, less than 7 can be represented by interval notation like that. And of course, on the number line, we have a 3 and a 7. And let's go to a different color. We take blue. 3 is included. 7 is not, so it's an open circle, a closed circle for an included value. And since these, whenever they do not indicate whether it's a natural number, a counting number, then we take x to be the real numbers. So we're going to include all those between 3 and 7, with 3 included, 7 not included. Number 3. Now, exactly my point earlier on. How would you like to view this? Would you like to go left to right? In which case you say naught is greater than x. So think of all the x values. Think of any x values. Naught must be greater than those x values. 0 is greater than which values? All the negative values. But then again, if you don't like writing it this way, then you can just simply switch it around. Because if you reverse the direction, you are actually going to state that x is less than 0, which I think is a little better. So for me, I would prefer having the unknown quantity to the left of the inequality, and then I read it from left to right. X is less than 0. And what will our interval notation be? Well, it starts from 0 and it goes everything less than 0. That means it's going to minus infinity. And infinity sign, we have an open bracket, a curved bracket, not a square bracket. And less than 0, that means 0 is not included, so that will also be an open bracket, indicating that the very last value of that interval, 0, is not included. What would the number line look like? Again, I don't think that will be a major hassle. You get 0, minus 1 to the left, 1 to the right, and you want to show that 0 is not included. And well, you can even look at the sign here, going that way there, very similar to that. So there you go, x less than 0. Okay, let's continue now. Go ahead with solution of linear inequalities. And like I indicated, these can be solved like you would solve normal equations, except for a particular case, or one or two cases, in fact. So let's take number 1. We want the solution. 3x minus 7 is greater than minus 12. Now, I know that you're familiar with this, so if I am going a little quick, I don't think you would mind. I'm going to transpose the 7, keep the inequality without changing it. That gives me negative 5. Then x is greater than minus 5 over 3. So what will your interval notation look like? Our interval notation, so that's minus 5 over 3. Is minus 5 over 3 included? No. So it's open brackets and it's greater than, so it starts at minus 5 over 3 and goes all the way to infinity. All the values from minus 5 over 3, excluding minus 5 over 3, all the way to infinity is part of your solution. I'm not going to draw the number line. Let's go to number 2. We have 2 times 1 minus x plus the 5 less than or equal to 3 times 2x minus 1. Yeah, once again, we can apply normal algebraic techniques. Distribute 2 into the brackets. 2 times 1, 2 times minus x minus 2x plus the 5, and on the right hand side 6x minus 3. We're going to transpose. Let's keep all the x's on the left, which means I'll keep the constants on the right. Transpose the 2, that becomes a minus 2. Transpose the 5, that becomes a minus 5. The 6 transpose from right to left, negative 6x minus 2 minus 6 minus 8x less than or equal to minus 10. Now we notice that in order to find x, we can proceed well, either way. We can first eliminate the negative, then divide by 8, or we can divide by a negative. But either way, we have to consider what happens to the inequality. I'm just going to do it the first way. I'm going to multiply by a negative 1. Now, when you multiply by a negative 1, then the sign of the inequality must reverse. Of course, minus 1 times minus 8x first, that gives you a plus 8x. Because we're multiplying both sides of the equation by a negative, the inequality reverses direction, so that becomes greater than or equal to, and then minus 1 times minus 10, that gives you 10, and now I can divide greater than or equal to 10 over 8. Now these are essential steps of the problem. You must remember that whenever you divide by a negative or multiply by a negative, the inequality reverses direction. Why? Why have you been doing that? Well, consider this. Consider this. Let's take a value, any particular value. 8. Okay, 8, right? Oh, I got 8, doesn't matter. 8. We know that 8 is less than what? 10. Now that is a true statement. That is a true statement. 8 is less than 10. And that's a positive 8 and a positive 10. I could have taken any two values on the number line where the one is less than the other. So 8 we know is less than 10. Now since this is an inequality, just like an equation, I can add values on either side. I can subtract values on either side. In other words, whatever I do to the left hand side, I must do to the right hand side. And I can also multiply by a negative. So let's multiply by the negative. 8 times negative 1. That gives me negative 8. 10 times negative 1. Whatever I do to the left hand side, I must do to the right hand side. Now let's analyze that. Minus 8 and minus 10. Is minus 8 less than minus 10 on a number line? If that is 0, where's minus 8? Here's minus 8. There's minus 10. So minus 8 is to the right of minus 10. Therefore, minus 8 is bigger than minus 10. So to make this a true statement, I have to reverse the inequality to obtain a true statement. And that is the reason whenever you multiply or divide by a negative value, you must reverse the direction of the inequality. Okay, let's continue. More examples. Number 3. Find m if negative m over 3 greater than or equal to 2m minus 1. So in number 3, let's solve that. Minus m over 3 greater than or equal to 2m minus 1. I'm going to multiply by the LCD, which is 3. Negative m greater than 2 times 3, 6m. 2 times minus 1, 3 times minus 1, minus 3. I will transpose minus 7m greater than or equal to minus 3. I'm dividing by negative 7. M becomes plus 3 over 7. Because I'm dividing by a negative quantity, this will reverse direction. Therefore, m less than or equal to 3 over 7. Once again, why can I go a little quicker? Because you have done this so often. Now, what about the next one? A double inequality. Well, you could call it by any other name, but I'm just going to call it double inequality. In other words, we have a case where 2x minus 1, for instance, is greater than a particular number and less than some other number. And we want to solve for x. Now, in essence, what we're looking for is to reduce it to this kind of an answer, where I get x in the center with values less than or greater than a particular case. So what do? We can do this again 2 ways where we can separate. In other words, we can say, let's first do that equation, get an answer. Then, once we've done that, we know this, of course, is less than or equal to 3. Then remove this one and solve for that. Then we have 2 equations, and then we can eventually bring them together and solve. But I prefer doing it all at once. In this case, you can. What do I mean? We know that we have to transpose the minus 1. So transpose the 1 in both sides of the inequality. So we'll leave the 2x, and minus 1 becomes a plus 1. So that will become plus 4 on the right hand side. That will become minus 4 on the left hand side. And then we're going to divide by 2. We divide both the left hand side and the right-hand side by 2. And there's your answer, x greater than or equal to -2, less than or equal to 2. Now, we're going to come across more of these in another section of the work. In fact, in the next video lecture. So recall how to solve those. Let's continue. Here we have our last two, and this is purely straightforward revision. 2 times x minus 1 greater than or equal to 5. This is an inequality. Many students make the unfortunate mistake of multiplying by the LCD when they have a fraction in which the variable appears in the denominator. Now, you must be careful because in essence, we have to consider signs. If we say greater than or equal to 0, and we have two quantities A times B, that means we're looking at positive answers, because greater than or equal to 0 is positive, less than 0 is negative. And if we are multiplying two quantities, that could be positive, that could be positive, because when I multiply a positive times a positive, I get a positive. But then again, both of them could be negative. So I end up with two cases, a case 1 and a case 2. And the same goes for the negative. But what if we have a fraction, a over b, less than 0? Then that could be positive and that could be negative, a case 1, or that could be negative, that could be positive, to give you a negative answer. However, if you multiply incorrectly, and I'm going to write here, this will be incorrect. If you decide, hey, hang on, there's a LCD, just multiply by the b, then I'll only have a less than 0. I don't have to worry about b. But that is incorrect. You have simply reduced the analysis of the signs and the inequality. That multiplication by the denominator, the LCD, is permitted when you're doing equations only, equal to sign. But the moment you get an inequality less than or greater than, you must leave that denominator. For example, in this case, you leave the denominator as it is. You transpose so that the right-hand side remains 0. Then what do you do with the left-hand side? You find the LCD but write it in. So you're subtracting two fractions. That will be 5 over 1. So x minus 1 into x minus 1, that goes 1, 1 times 2, then 1 into x minus 1, that's x minus 1, so that would be 5 times x minus 1 greater than or equal to 0. Let's multiply those minus 5x plus 5, leave the denominator. This gives you negative 5x plus 7 over x minus 1 greater than or equal to 0. Now, you can solve this inequality as it stands by considering different values. But what I would prefer is to take and eliminate this negative sign here, so that the x's are first in both the numerator and denominator, and they are both positive. So how do I do that? Well, simple. You multiply by a negative 1. Now, once again, you're multiplying by minus. Again, something that I just want to bring. When I say minus 1, I'm actually multiplying by minus 1 over plus 1, which means the numerator minus 5x plus 7 is multiplied by -1. So that will become 5x minus 7. The denominator is multiplied by +1. So the denominator remains the same. In other words, when you multiply a fraction in an equation or inequality by a -1, only the numerator will change sign, the denominator stays the same, or the denominator changes sign, the numerator stays the same. But what else? Is that correct? Well, absolutely not. Why? Because we just multiplied by negative. And what must happen? We just had a discussion on that. The inequality must change direction. Now, when we get to this stage, we now have it at a particular point where we can analyze the signs. And how do you do that? Well, we're going to do that by critical values. Now, once again, guys, how you did this at school just depends on the teacher or whatever you've learned. I'm happy with whatever you do. I prefer doing a number line. What I do is draw a number line. I look at the denominator, which is x minus 1, and I find the critical value of x minus 1 by placing it equal to 0, which gives me +1. So my critical values are either 1 from the denominator and from the numerator 5x minus 7. So I'm going to say 5x minus 7 equal to 0. X is equal to 7 over 5. 7 over 5 is my critical values. So on the number line, I will have a 1. I will have 7 over 5. Now what I do is very quick, and I'm not sure whether or sort of what depth I should have this discussion. But let's do it. Let me do it, the first one. So what I tend to do is I draw this down there because there's two values, two critical values, right? The first critical value, 1, comes from the factor x minus 1, in this case in the denominator. The second critical value, 7 over 5, is obtained from the factor 5x minus 7. And then once I have those, so for example, I could have 3 factors over here. I could have 4 factors. Then I would have 1, 2, and so on. How many factors depending on the equation that I'm dealing with. Now, so what I'm actually doing is creating yet another number line for x minus 1. Now, x minus 1, what makes it 0? 1. So I'll put a 0 there by the 1 for that x minus 1. For 5x minus 7, what value makes it 0? 7 over 5. So I'll put a 0 over there. So now if I look across, maybe I should take, if I look across x minus 1, yeah, I've kind of created another number line for x minus 1 in which it's 0 at 1. And here I've created another number line for 5x minus 7. So if those are number lines, it very simply means that to the left of 0 is negative, to the right of 0 are positive values for x minus 1. For 5x minus 7, to the left of 0 is negatives, to the right is positives. And now you divide, just like you divide over here in the question itself. Positive divide by positive gives you positive. Positive divide by negative gives you negative. Negative divide by negative gives you positive. And this will provide you with your final answer because you are looking for negative. Why negative? because it's less than 0, less than or equal to 0. And there's negative. And negative lies between what? 1 and 7. So there's your answer. X is between 1 and 7 over 5. So X is greater than 1, less than 7 over 5. There's your answer, except for one thing. This is a greater than or equal to, which means I'm going to put a greater than or equal to. Oh my. Let's just go. Okay, at this stage, we will stop that. Please complete that. I will try and get back to our video presentation. I'm having problems with Wi-Fi. Okay, let's complete this. So this is an equal to sign. We'll put an equal to sign there, but we cannot put an equal to sign by the 1. Why? Look at the denominator. The denominator at the very beginning is x minus 1, and that x minus 1 cannot be equal to 0 in x cannot be equal to 1. So despite the fact that this is a greater than or equal to sign reduced into a less than or equal to sign, I can put a less than or equal to sign for 7 over 5, but not for 1. Now I would like you to do number 2, and I'm going to stop this video lecture here because of our Wi-Fi connections.